So far we've been looking at the gradient intercept form of an equation for a line. There are other forms. There's what we're going to talk about today, which is the standard form. That's where x and y are on the same side and it is equal to a constant. There's a gradient point form, and there's actually a two-point form which effectively calculates the gradient in its process. But this is the other one we're going to need at the moment, because we need to be able to write equations in this form so we can solve systems of equations when they're given like this. You could always rearrange, and I might do that as an extension at the end, is rearrange one of these to see what equals mx plus c. The technique is actually quite quick, quite easy. What you do is you make a number of hypotheses. You start asking things like what happens when x equals 0. So if x equals 0, I can eliminate this term. Now, some people call this the cover-up method, and that's where you take one of the terms, you want to get rid of it, so you cover it up. We're now left with an equation that I can solve, which is in terms of y. So I can start writing, if that's the case, then 3y equals 12. Divide both sides by 3, and it says y equals 4. So that gives me one coordinate. X is 0, y is 4. Well, that gives me one place. I need a second one. So that gives me a point on the y-axis. The other one is, let's see what happens on the x-axis. So let's move my hand out of the way a moment. And to find where that is on the x-axis, we want to point somewhere along here. And we do the opposite thing. We say, what happens if y is 0? And what happens in that condition is, if y equals 0, if y equals 0, we now have 4x equals 12. That solves to divide both sides by 4, x equals 3. So I now have another coordinate, which is at 3, 0. I'm not going to keep doing the cover-up method. We don't need to. You get the idea. You can cover up one term by saying it is the variable inside it is 0. So I don't need the hand anymore. I have my second coordinate. Y equals x equals 3 when y equals 0. And like I've been doing in the other ones, let's draw in a nice straight line. It goes somewhere about there. There we go. And again, write the equation on the end. And this was 4x plus 3y equals 12. Notice when everything's positive, you wind up with a negative slope. It's to do with the way of rearranging things. If you wanted to calculate the gradient, this 4x would have to go to the other side, so it then divides by 4. Just a quick note on the gradient. It's a minus 4 over 3. It's actually related to these two values here. They do actually tell you the gradient. If they're both the same sign, it's a negative gradient. If they're different sign, it's a positive gradient. So talking about that, the red one, we're going to get a positive gradient, and it's going to be a positive gradient of 5 over 3. Let's go through the same process though. Let's say if x equals 0, that tells me that minus 3y equals 15. Change all the signs, including the equals. The equals changes to itself. But if these are inequalities, it would have to flip, and that says y equals minus 5. So we've got 0 minus 5 as 1 point. Second one, y equals 0. That leads to 5x equals 15, which is x equals 3. So we go through 3, 0 again. That point. Take my line, draw it straight through using a ruler. Let's go from somewhere there to through that line. Keep it going out that way. And label the equation. It's 5x minus 3y equals 15. Okay. And that's how you can keep doing lots of equations like that. They're fairly straightforward. Gradient, as I go from there to there, I'm going up 5 and right 3. So 5 over 3 is the gradient if you're doing gradient intercept form. It does give me the intercept when you do this calculation when x equals 0. That's the x-intercept. So I know this equation should be y equals minus 4/3 plus 4. These other two equations, they're a weird form of this. They tell you what the x is. So it says x equals 2. That tells me that it goes to a point 2, 0. But where else does it go? Well, what it's saying is I can tell you nothing about the y value. It's never going to go to a y value that I can use. I can't find a y value intercept because there is no y in this equation. What it actually says then is this runs parallel to y. Because I can't find a y value, I'm going parallel to it. If you look at the points as we go along them, every single coordinate here, this is going to be 2 minus 4, this one's going to be 2 minus 2, is 4, 2, 2, 4, 6, 4, 2, 4. So all of these points along here are in this positive direction. So I'll make a little note that this is parallel to y. Because there's no way for me to say y is equal to something. It cannot cut across it. So look at the next one, the y equals minus 3. Well, that tells me 1 point, 0 minus 3. That's a point that I know is on the line. And there's 0 minus 3. So 0 across, 3 down. And this now says I have no x value, so it must be parallel to the x value. So parallel to x. And I can draw a line through. Yeah. One colour, I'll change the colour for us. There we go. And again, if you go through all of these points, we've got minus 5, minus 3, minus 2, minus 3, 1, minus 3, 4, minus 3. All the y values are minus 3. This tells me that form. That's how you can use the cover-up method to solve simultaneous equations in the standard form.